Hello, everyone, and welcome to today's masterclass on Kubernetes and Containers. I am very excited to be here today, and thank you for joining. A quick intro of me. I am Simi Joshi, part of Oracle for Startups, Marketing and Events team JPAC. Before I invite our speaker to present today, let me introduce him to you all. Vikas Rana is a member of our cloud architect team and helps the startups to migrate their workloads from different cloud providers to Oracle Cloud. Vikas is a lead architect and mentor with Oracle. In his free time, Vikas promotes cloud technologies as dev advocate. In the masterclass today, we will introduce you to Docker, containers, Kubernetes, and how they work together. Hope you find this session insightful. And if you have any questions during the session, just pop them in the Q&A window. We have Mitesh, we have Nagaraj, who will help you to answer all your queries and questions. Over to you, Vikas.
Thank you, Simi. Here at Oracle for Startups, we work very closely with startups, enabling them to develop their applications and their platforms on most modern cloud technologies. And one of them is Docker, Kubernetes, and containers. Hello and good morning to everyone. My name is Vikas Rana, and I'm Senior Principal Cloud Architect with Oracle for Startups program. And I am really delighted and honored to be conducting this masterclass for you guys. A lot of you would know me by their association with this program, but in case you do not know me, I have been with part of this program for last 4 years. I am a cloud architect, but I also play the role of dev advocate and cloud evangelist. You can find me on LinkedIn on the link given below, and if you want to access the blogs that I write, you could access my blogs on Oracle site. So let's get started. Let's look at what we have for agenda today. Our agenda is pretty simple. We're going to talk about Dockers, Docker containers. We'll do a demo on containers. We'll talk about Kubernetes, how they work with containers, and finally we'll do a small demo on Kubernetes. We'll look at the deployment and we'll look at how we can orchestrate this deployment. We are covering a lot of stuff here, so I probably will skip few of the topics which we may not be able to condense within this presentation, but I would encourage you guys to pop up your questions on Q&A and the chat box, and we'll try to answer those questions online as we go forward. But in case there is a question that requires some kind of a conversation, or it requires some kind of links and more information, I promise you I'll get back to you via email or maybe through a Zoom call on one-on-one. Having said that, let's get started. So what is Dockers? We keep hearing about Dockers and we keep hearing about containers. So what exactly is Dockers? Dockers is an open source containerization platform which allows developers to create their own work areas on the server and run their applications. It allows you to create a completely isolated environment. Now, when people use the word Docker, they probably mean Docker containers, but when you say Docker is a company's name. Docker is not the product. Docker company has a lot of products. One of them is Docker containers, Docker engine, or the product that they offer is Docker Swarms. So Docker is not the product, Docker is the company's name. So what Docker does is it provides it provides an engine on which you can create your containers. Those containers are completely isolated. It allows sharing of resources on the server. Docker containers, they bury this debate of if you are in development lifecycle, this debate of, hey, it works on my machine, but somehow it's not working in some other environment. That debate is completely buried. Docker is one of the most widely popular containerization engine that is available in the market. And Docker also allows you to not only use the base images, but also allows you to modify those base image and then use it as a new image. And all the stuff that I'm talking about, we'll talk about it in detail as we go forward. So that was about Docker. So Docker provides an engine for us to create containers. So now what is container? Container is nothing but a software package that has all the dependencies and all the libraries related to the application, and then it's packaged and exists as a standalone item. Imagine if you want to wrap your head around this concept. Imagine a sea where there are multiple islands. So each island will have its own environment, its own trees. Maybe somewhere you can see banana tree, somewhere else you may see pine tree and stuff like that. And it has its own small piece of land. But if you go, if you dive deep, you will see that all these islands, they share the surface with the sea. They all have common surface from which they have been derived. They all kind of share the beach, the sand that they are using is common to all of them, but they are standalone entities. Similarly, your Docker containers are standalone entities, completely isolated, as if nothing else exists on the server. But deep down inside, they use the resources of the server, which is your RAM or CPU or memory or networking. They kind of use those resources. They derive it from the server on which they're hosted. So you can run multiple containers on the server. You can run, if you want, you can run 1, you can run 10, you can run 100. So there is a efficiency in utilization of resources on the server, and that's a big thing when it comes to cutting down on expenses. One advantage of Dockers is that Docker containers is that you can stop them at any point in time. You can terminate them. You can respawn them. You can package them and port them to any other machine that you want. You can develop a container on your laptop and then deploy it on any server that you want, and the whole process probably will take few minutes and not more than that. So Docker provides us the engine or the platform on which containers can be created, and containers are standalone entities that have all the resources that are required to run your application or platform encapsulated inside it. So containers were around. The concept of containers were primarily derived from virtual machines, but containers were around for some time. They have been around since 2012, 2013. But what got them fillip was development of or expansion of DevOps and microservices. Both DevOps and microservices are kind of natural allies of containers. If you are using containers, you can very well use microservices architecture. And then if you are in a big organization where you're using DevOps, containers kind of provided you that leeway so that you could from end to end, from development all the way to the release or production deployment, containers provided you a very easy kind of a pipeline development. Also, the fact that hardware is shared among the containers reduced the capex and capex of the companies. So that was a big thing for companies, and flexibility and scalability. When it comes to scalability, containers beat virtual machines by a huge margin. You could set up hundreds and hundreds of containers on a given VM, and they kind of utilize the space as much as is required. They kind of utilize the CPUs or the networking as much as is required. So there is a efficient 100% utilization of your base resource. So what's the difference between virtual machines and Dockers? So virtual machines, typically you will have a bare metal machine on which you will have the hardware, and then a host operating system is deployed, and then on top of it, hypervisor is deployed. Now, hypervisor is a virtualization technology that was the most common one is from VMware. Now, what this hypervisor does, it kind of provides a abstraction of the infrastructure, abstraction of the hardware. So on top of it, if you create a resource which we will call as virtual machine, you can deploy your own OS. It could be Windows, it could be Ubuntu, it could be Linux, it could be any operating system that you want, and it's called as a guest operating system. And on top of it, we deploy our binaries and libraries, and also deploy our application. Now, virtual machine is something that anybody who is on cloud would have used extensively. So we don't care about the underlying server that is there. All we do is we just set up our operating system, deploy our application, bam, all set. And this virtual machine exists as a standalone entity, and it doesn't share any resource with any other virtual machine that you would create on the same server. So there is no sharing of resources per se. Now flies in Docker. So what underlying infrastructure Docker is same. You have a bare metal machine on which there is a host operating system, and it could be any operating system. Now, instead of hypervisor, and remember, hypervisor is a pretty expensive item out there. So instead of hypervisor, we have Docker engine. We install or deploy Docker engine top of host operating system, and then on this Docker engine, we can create our own containers, and we can create multiple containers. Now, there is a similarity here that just like you can create multiple virtual machines on your host server, you could create multiple Docker containers on your host server. But the key here is that there is no guest operating system here. which means Docker containers are extremely light. Docker containers are extremely portable. Docker containers use resources to the max extent possible, all because A, we are sharing the resources, two, there is no guest operating system deployed here. So if we compare virtual machines with containers, we'll see that virtual machines are kind of slow, lethargic, to the extent that in few years probably we'll call them primitive, and they occupy a lot of space. And portability is a major problem in case of virtual machines, whereas containers are quick, lightweight, they are highly efficient, occupies very little space, and above all, they can be ported very quickly from one machine to another machine. These two machines could be with the same cloud service provider, or it could be across cloud service providers. So there is no lock-in here. There is no pain of I cannot migrate it, or migration itself will take huge amount of time for me. So how does it work? What was the underlying philosophy of Docker and Docker containers? So the basic philosophy is you build it once and then you run it anywhere. You can take your, I'm going to use this word image and I'll talk about it. You can take your image anywhere and then you can run that, deploy that image on any machine and then run it. Again, it could be your own laptop, your PC, or it could be your server or your bare metal machine. So how does it all come together? You will have a Docker file which has all the instructions related to what I need to do, what kind of container I want to create. So Docker file will create a Docker image for me. When I say Docker image, it is nothing but a static version of Docker containers. A good example would be if those who have lived in the 90s, probably none of you, those who have lived in the adult age of in 90s, we had those black and white pictures, or if you go to a movie theater, we used to have these reels, big reels running in that projection room, and then you will see the picture. So those reels were kind of Docker image. So they were static, but once you put them in the right place and right frame with the right amount of lighting, suddenly everything would come alive. So Docker images are nothing but for object-oriented folks, Docker images are nothing but a class, and Docker containers are instantiation of those classes. Okay. Please feel free to put in your questions in the chat box if there is something that you're not clear with, and I would like to, I would happily go back and talk about it. So Docker file typically will have a predefined structure, and you run a Docker command to create or download or deploy the image. You build the image and then you run the image, and then you can create 1, 2, 300,000 containers out of that single image. So how does it all work? So Docker engine is primarily based upon this concept of client and server. So you have client from where you can pass all the instructions to your Docker server, and Docker server based upon your instructions would work with the images and then create containers for you. Once the containers are created, then you can work with the containers and whatever you want to do with the containers. Now I'm speaking about images, but where do I get these images from? So Docker provides you over 100,000 images as public images from its repository. So you can download any of those images from Docker repository, and they are called base images. You could download all the images that we work, most of the images that we work with, most of the software that we work with are available as publicly available images in Docker's repository. So you could have a PHP image, or you could have a Nginx image available there, and you could download these images free of cost into your server and then work with those images. And from those images, you could create your own containers. Okay. So that's about how Docker containers would work. Get the images from Docker registry, get into your local machine. From those images, create your containers. As simple as that. And all this is orchestrated through a Docker file. So it's here is a sample Docker file. So it's a very common kind of architecture that we see. It's a WordPress website along with MySQL database, which is extremely common. And all I need to do is just execute this particular Docker file, and I will have a WordPress website up and running. So there are a few sections in this sample Docker file that we need to focus on. It talks about the service. If you see this part here, it talks about the service. So I'm going to create a database service, and my database is going to be MySQL 5.7. This is the version I'm using. I can, in some places, you will see :latest attached to it. So I can use any version that I want. If I don't provide the version number, then obviously it's the latest version that is being used. Otherwise, I can provide a specific version for the image that I need to download. Images you can download from Docker's registry, but what happens if you have modified the image? So you can also modify and upload those images into your private repository. Oracle Cloud offers you private repository which you can use, or you can find a space in Docker's registry and upload your images, which can be made public, or you can have your private repository, private area where you can upload your images if you don't want to share it with the rest of the world. So here is structure of a sample Docker file. Pretty simple, pretty straightforward. The only thing you need to be careful about is these files are very particular about the structure and any space that comes in. So you need to follow the standard file structure as is. And if you look at it, anybody, it's very intuitive by display. You have we are looking at MySQL image. We are looking at a WordPress image, and what we are saying is we're going to create containers which are going to run MySQL and WordPress. So with this file, I am going to create two containers. One will run MySQL database, other will run my WordPress, and then I have some of the environment variables like root passwords and DB host and passwords that I require, access that I require, and also I am creating a database called WordPress in MySQL database so that I could use it later. So I can extend this file to max extent possible, but it's a very simple kind of demonstration that of a sample Docker file. And it's demo time. Let's see what actually I mean when I spoke about so many things. What exactly was I meaning by that? So here I am on my server. This server is a virtual machine existing on Oracle Cloud, and I have deployed Dockers on it. Deploying of Docker is pretty simple. It's a single command that is available. You could find this command in one of my blogs, or you could just Google for it. And this command is very simple, straightforward. You could run this command, and your Docker engine is up and running. Not much is required. Very intuitive. So I'm here, and what I'm going to do is So I'm going to use Docker Compose command to set up my containers. And we'll see the structure of this Docker Compose file that is there. It's the same file that we saw in the presentation. I have my MySQL image that I'm going to download. I have my WordPress image that I'm going to download, and then I'm going to work with it. One of the things that is pretty important is port. Now we know applications work with ports. If I'm going to access the application, it work with ports. Now here are two entities that we're talking about. One entity is this server that is there on which I'm going to deploy my container, and the other entity is the container itself. So we are looking at two different ports now. So ports is something that we define in our YAML file, in our Docker Compose file, so that we predefine where I'm going to run this particular application. And we'll talk about ports in detail when I come to Kubernetes, because ports are very important when we talk about accessing the applications. But for now, let's understand that we need to define the port. And since WordPress comes with Apache server, and we need to have it runs on port 80. So port 80, this port 8000 is the port which is defined on my server, the server on which I'm going to create the container. And this port 80 is the port of the container where I'm going to run this WordPress application. All right. So this is one. And also see the speed of execution. Now, there are a lot of Docker commands that are available. This command is going to show me the images that are available in my local machine. So as I see, there is no MySQL image or there is no WordPress image currently available in my local machine. So when I use this command, Docker Compose up, it's going to execute the file that we saw, and it's going to download the images, and we'll see that. It's going to download the images, it's going to download WordPress image and everything and anything that is associated with that WordPress image. It's also going to download MySQL image and anything and everything that is required to run MySQL database in a container. So it's going to download the image. Image will have all the dependencies and libraries encapsulated in that image. And all we have to do is just run it. And in a couple of seconds, we'll see the containers are up and running. Having said that, first time it takes a bit of time because it's downloading the image from the server, from the Docker registry. So that's why you're seeing that it's taking some time. So, okay, it's already running. So it's taking some time in executing it. But if I stop it now, let's say if I stop it now, once the images are already in, if we see the images once again, so now I can see my WordPress image and my SQL image is available in my local repository. So if I again run this, so boom, it's running. It took me less than 2 seconds to make it up and running. So my containers are running. Let's open a shell of copy of this server and let's see what is running. Okay, so something which is very interesting, and we talk about containers. We talk about containers as standalone entities, similar to not same, but similar to virtual machines, that they are completely isolated and everything. But if you look at it from admin side, containers are nothing but processes running on the server. So if I want to see my WordPress and my MySQL containers running, I have to do Docker PS. So these are my, see here, my WordPress is running, my MySQL is running. All right. Now, so I have set it up, my containers are running, and we'll see how I can, what is that I need to do. Let's say if I want to SSH into this, where is the name? Okay, here is the name. If I want to SSH into this container, okay, because container, we just said that containers are nothing but it's a similar to a working environment that I'll get. So I can simply jump into the container by providing this parameter, and I will get into the bash shell. Here, now I'm inside the container. I can now make any change inside this container, and that change will get reflected. Now, I spoke about base image and then modified image. What I meant by that was, now this is a very very vanilla kind of a WordPress website, and we'll see the website in a couple of seconds. It's a very vanilla kind of a website, WordPress website, which is available. But if you are working with WordPress, you probably will need to make changes. You will talk about to say, let's say, welcome to my website and all this stuff. So how do you do that? So you'll make those changes here, and then from this running container, you will take a copy of the image. It's just like taking a snapshot of the image of the container. So you take a snapshot of the container and then use that image next time when you work with your WordPress website, which means all the changes that you have made are already captured, and then it works with the new image. And this image you can upload back into Docker's registry, or you could keep it in your local server and migrate it, or you could put it in the private repository, and every time in any other environment, if you want to run the same image, you could just run this command, and pretty much it would work for you. So I'm going to get out of it. And before we go any further, there is one concept of containers that I want to now bring in. That is, containers are by nature very ephemeral in nature. What I mean by that is, containers, we don't have control over the life cycle of containers. Containers are created and destroyed, all the time. So as soon as a container is destroyed, ideally it takes away all the information that was associated with that container. Which means that if I have made the change to the container, or if I have stored some information, it's a database and I'm storing the information inside the container, the information is lost forever. So you really cannot use a container unless and until you decide upon how do I capture the information which is being generated when you are running the container. So for that reason, we also look at volumes. We also look at persistent volumes, which means if I'm making a change, it's not really stored inside the container, but it's stored somewhere outside the container. It could be on the node that I'm working. It could be on the server where the container is generated, or it could be some external source where I can store the information. Because again, containers are very transient in nature. So containers can die at any point in time, and then it's not possible to retrieve the information that container took away with itself. Okay, so
just a minute, Vikas. We
yes.
had Jayasudhan raise his hand, so maybe he has a question. I don't know, Jayasudhan, if you have a question, it would be great if you can type in the Q&A session.
Jayasudhan, we'll answer your question towards the end, but if it is something that can be answered via text, please post your question on the Q&A chat, and Mitesh or Nagraj would answer that question. And if it is something that requires a bit of discussion, then we'll, towards the end of our session, we'll take up your question and answer the question. Okay, so the IP address, the server that I'm running has this public IP address. And then what I'm going to do is I am going to, okay, just put it here. I am going to. So this was my port number, and let's see what it brings up. My WordPress website is up and running. So after that, I need to do my configuration, and I have to associate with the MySQL database, providing all the information that is there, and then I can set up my website, and my WordPress is up and running. So what have we understood from all this is that containers are small standalone entities which can be created in hundreds on a single server. They can be ported very easily. They are very lightweight, which means anytime a container gets created, a new container in its place gets created in less than 2 or 3 seconds. They're very fast, they're light, they don't occupy a lot of space, and they share resources on the server on which they're existing. Last thing, containers are ephemeral in nature. They get created and destroyed all the time. Things change very fast. Once they die, they take away all the information along with them to the grave. So the information that a container generates, or the modification that we have done to the container, that needs to be captured either in the image itself, and we create a new copy of the image which exists on top of the base image, or we create a persistent volume where we can store the data. Going back to the presentation.
Time check, Vikas. We are nearly 11:30.
Oh, perfect. We are on time. This is wonderful. So, so this was about containers. Now comes the problem of, what do I do with containers? It's very nice to show it in demo that, oh, there is a container. I've created a container and it's working fine. So what if this WordPress website was getting a lot of traffic? What would I do? Simple answer is I would scale it up. How do we scale it up? Just like we do it in case of virtual machines. Here also, instead of 1 copy of container, I'll create 10 copies or 20 copies of containers from the same image. So I'm running 20 containers now. Fine, but how do I manage it? What if 3 of the containers die and I have no control over those containers, on their life and death? I can create the birth, but I cannot create the, stop the death of the container and all the information that it takes away from me. Or what if I want to, you can't have a person sitting there and creating containers, or scaling up and scaling down based upon when the spike would come. So those are practical challenges. To sort out those challenges, Kubernetes came in picture. Now, Kubernetes is a platform or application that was developed primarily by Google to manage their containers. And at some point, Google kind of donated it to Cloud Native Foundation. And now it's an open source platform which is available for anybody to use. It's an orchestration platform. So a lot of people use, kind of get confused between Dockers and containers. I think that is the same thing. But Dockers is what provides the containers, and Kubernetes is the orchestration platform. Kubernetes has no meaning if containers do not exist. Kubernetes exists because of containers. It's purely to orchestrate those containers and how those containers kind of interact with each other. It's a complete lifecycle management tool from cradle to grave, from the creation of container to the maintenance of those containers, to the death of those containers, or destroying those containers, terminating those containers. Everything is controlled by Kubernetes. There is a very interesting concept in Kubernetes which is called as it tends the flock, not raise a pet. What it means is that single container has no significance or value for Kubernetes. Kubernetes is looking at the overall bigger picture. So one container can get created, can get destroyed. Kubernetes orchestration does not care about that. The only thing it cares about is that the overall big picture that you have created, and I'll talk about the big picture also. Overall big picture that you have created, it should remain like that. It should not change. If it changes, then again it readjusts the whole thing. What does Kubernetes offer us? What are the features? So Kubernetes, like I said, it's a container management and orchestration tool. It lets you deploy and maintain your containers. It also lets you monitor the state of your containers. You can auto scale, and this is very important in case of production environment. You should be able to on the fly able to auto scale your nodes and pods, which means you can set up the conditions based upon which the number of pods would increase or number of pods would decrease. Same with the nodes. It helps you in networking, service discovery. It can also set up load balancers for you. And because of the fact that you are using Kubernetes and Kubernetes does not work with just one container, you're looking at multiple containers. So high availability is always maintained for your application. Okay, now I've thrown in a couple of words here and we'll talk about that. One of them is pods. But before that, let's talk about the architecture of Kubernetes. Kubernetes architecture is again based upon a master server and a worker server. So in case of a cluster, you will have one master and multiple servers, or sometimes even more than one master and multiple workers. Workers, when I use the word workers, these are typically nodes or typically your servers where your containers are running. Kubernetes master is composed in itself is composed of 4 different services which run, and once you set up something as Kubernetes master, it will run 4 services, and those services are your API server, which would help you engage with your workers. Then there is scheduler. Scheduler kind of maintains the schedules the pods on your worker nodes. You have control manager. Control manager controls the overall health of the entire cluster, which means it keeps sending those heartbeats to the worker nodes and keeps checking if a given container is alive or not. If it is not alive, if it doesn't hear back from the container, then obviously it will create something else in its place. And then finally, it's the etcd server, which is nothing but it stores the current state of the cluster. So you have current state of the cluster, you have the desired state of the cluster, and it should always match. So what is the cluster? Cluster is nothing but collection of servers, your master and your worker nodes clubbed together, they are called as cluster. So when somebody says Kubernetes cluster, what they mean is worker and master node. So it could be 1-to-1, one worker, one master, one worker. It could be 1-to-many, one master, multiple workers. Master node is where all the administrative tasks happen. Typically, we don't create containers on master node. Master node is meant for running these administrative tasks. Worker nodes are servers where we run these containers. And we spoke about pods. What are pods? Pods are a logical entity. They don't really exist as such, but these are logical entities which help us draw a fence around our containers. So if I have, we saw that there was a WordPress container and there was a MySQL container running on the server, but these were like orphan kind of containers running there, and accessing them would require me to go to each container and work with that. But in Kubernetes, for better management, we create a logical fence, a virtual fence around my containers. I define that fence when I'm creating those containers, and that fence is called as pod. Pod is the entity that typically we engage with. We do not directly engage with the containers. It is the pod that gets engaged, and then through that, containers get engaged when you are trying to talk to a container. And container, we know, is the most atomic lowest unit of existence where your application starts. So what's the profile of a pod? Pod is a logical fence around your container. So I could have one container running inside a pod. I could have multiple containers running inside a pod. Like I said, containers, Kubernetes is not really concerned about the containers per se. It is more concerned about the pods. Pods, like any other resource that gets created in the cloud, pods also get their own private IP address. So once we create a pod, it will have its own private IP address. So IP address is assigned to a pod and not to a container. Okay. Whereas if I create a standalone container, then I will have some private IP address of that container. Pods are defined by a YAML file. It's very similar in nature to what we saw with our Docker Compose file. If you once you get acquainted with these YAML files, they kind of look very similar in structure and in nature. So they are controlled by a YAML file. And when a pod is created, it's tied to a node, which means a pod for its lifecycle. You cannot move a pod from node 1 to node 2. You will always have, once the pod is created, it's tied to a particular node and it stays there throughout the life cycle of its existence. Just like containers are very ephemeral in nature, they get created and destroyed all the time. Pods also do get created and destroyed all the time. And one of the tasks of this Kubernetes orchestration platform is to make sure if the pod is terminated abnormally or if it's unhealthy, it's no longer in use, then create another pod in its place. So there is a constant watch by Kubernetes engine to keep pods up and running and keep looking at their health. Okay. So most important thing is communication. So whether it's a virtual machine which is existing on some server, or whether it's a container, or whether it's a pod, end of the day we need to interact with it. We need to engage it. When I say we, I mean the programs. It could be a external entity that is engaging with my container. I have a WordPress application running on a container, and now it should be exposed to the world over the internet. Or it could be my MySQL database, which should be private, and it should not be accessible from outside the cluster, but inside the cluster, yes, WordPress should be able to engage with this MySQL database container that is running. So pod communication is extremely important when you are designing a microservices architecture. Like I said, pods, as they are created, they are assigned private IP addresses. So every pod which gets created will have its own private IP address, and inside the pod there is a container. There is a container, there are containers. It could be either way. So how do we? Let's say I have a pod which is running both WordPress and MySQL database. So if only my access is only up to the pod, so how do I access MySQL or WordPress database? What is that which tells me that, hey, with this you can access this container? That comes through port. We spoke about port earlier, where I said that port is your applications run on port. So if I have multiple containers running inside a pod, I will assign them to a port. And through these ports only, I will engage these containers. So it's combination of pod IP address and the port on which the container is running will give me access to that particular container. Now, this again has many flavors. I could just, if I'm running it on localhost, I could just say, I could access this using localhost as localhost and the port number, and then access the container. Or I could use service name. I could create a service. Now, service is another one of the concepts that is part of Kubernetes, which is basically which comes in handy when you are talking about communicating with the pods. You could create a service, and you could interact with a given container or a given pod. There are few more ways of interacting with these pods or these containers, depending on what kind of use case do you have. If you look at it, I said pods can be created and destroyed all the time. So if I have a pod and I have IP address of the pod, and I'm using that pod, and then it gets destroyed and the new pod is created in its place, what happens to my IP address of that pod? That is gone. So now suddenly I have an IP address against which there is no pod existing, whereas I have a new pod there, but I don't have access to this pod because I don't know the IP address. So the concept that was used in virtual machines, that was used in auto scaling feature, which is to create a load balancer or load balancer like entity, which is cluster IP, and then assign that cluster IP to a set of pods. So instead of managing individual pods, we are now providing them a virtual IP address, and through which I can access one of these pods. I do not know which pod my request will go to, just like load balancer. And internally, if you are using cluster IP, it typically understanding is that it works on round robin kind of fashion. Though it's not really round robin, it's more of probabilities. But if you have 3 pods and probability of each pod receiving a particular communication is roughly 33%. So we kind of say it's round robin, but it's not really round robin. So cluster IP is a dummy IP which gets created. So just like a pod kind of encapsulates containers, your cluster IP encapsulates the pods that are defined within that cluster IP and provides an IP address, and it resolves through that IP address where the communication should go to. Okay. Again, this requires a bit of more explanation in terms of how this communication happens. There is something called node port that you can use if you are using external services. Then the load balancer comes in picture. You could create load balancer through your Kubernetes commands. Cluster IP could be created through Kubernetes commands. So there are multiple ways of interaction with your pods and your containers. But it all is handled through the IP address that is assigned to a given pod. But in real environment, we don't really use individual pods IP address. We create a load balancer or cluster IP. Cluster IP typically is used for internal communication when you are inside the cluster. But if you are trying to engage your services or your applications from outside, you would most likely use a load balancer, which is the right way of going about it. Okay. So what we see here is a pod deployment file. It's a pretty simple kind of a file which would deploy a Nginx application. It will create a container which runs Nginx application inside a pod. Now, if you look at it, it's very similar to what we saw earlier, the Docker Compose file, very similar nature. So here I need to define the API version, the version of this, the resources that I'm going to create. What kind of deployment it is? It could be a deployment. It could be a service that I'm going to create. Then the name of this is all metadata. So name of my deployment, my label for this particular app that I'm going to use, and these things you use once you get into a scenario where you're using deploying multiple pods, multiple containers, and you're working on multiple projects simultaneously. All these things do come in play. So the use case is when you are scaling up at a large scale. All these things do become important, because then you kind of create another fence around your deployments, and I'll talk about it when I go to actual demo. And then we have specification of containers, my container name, what kind of image I want to use. Remember, image is something which is common to Docker, which is common to Kubernetes. Everything works on image. You need to have an image. Image creates my containers. So you need to define the image, what kind of image I'm going to use, and from where I'm going to get this image. And finally, I have to define my port. My application is going to run on this port, which means if my container is inside a pod will get the IP address, maybe 10.0.1.10 kind of a thing. That address along with this port number will identify my Nginx application. And if I'm running multiple containers, multiple pods of this particular application, then I probably will create a cluster IP. So all these pods will get a common common private IP address, and I will access my container through that IP address, and based upon whatever logic is being used, one of the containers or one of the pods will get engaged. Last thing and very important thing is the status. Status is not defined in this file per se, but status is something that Kubernetes maintains. Status is all about what is my desired state of cluster. So let's say my desired state is that I want to run 10 pods, and at some point in time the system realizes that only 9 of the pods are alive and 1 is dead, which means my desired state and my current state are not in sync. If they are not in congruence, Kubernetes will create one more pod. Or if I have used a command to scale up my pods, so then again Kubernetes will maintain that state as long as possible. So your desired state versus your current state, it should always be in sync. If it is not, Kubernetes will take care of it. So the whole orchestration and management is done by Kubernetes. The monitoring is done by Kubernetes. So it kind of makes our life pretty easy and simple. So let's go to demo. So for this demo, what I have done is I have used Oracle's Kubernetes platform. Let's go here. So you could do this exercise. You could set up your own VMs. There is a complete configuration process that needs to be done in case of using Oracle's Kubernetes clusters. This whole deployment configuration of your servers or nodes is kind of simplified, and all you have to do is click on this cluster, provide some values, and boom, it's done. So you don't have to install so many softwares, and you don't have to worry about so many softwares and so many configurations that needs to be done. So what I have done here is I have this 3-node cluster that I have created, and what I'm going to do is I am going to use Cloud Shell. for this, just for the management of my Kubernetes cluster. So a disclaimer, I have downloaded a publicly available set of microservices which are available publicly. So I'm going to use them because it gives us a nice preview of how microservices work through containers. So instead of now running just one WordPress website or running just a simplified Nginx server, so this is a complete website. And what I have done is I am running individual services as microservices in this particular architecture. So instead of a monolithic architecture where everything is clubbed inside same code base, here I'm going to run multiple services, each one running its own in its own pod, in its own container. And through those microservices, we'll see how it all comes together. Okay. So this is something, if you are going to in future develop your architecture or move your architecture from monolithic to microservices, this kind of gives you a good idea about how my microservices, how I can use Kubernetes to set up my microservices and how they would look like. Okay. So what I'm going to do is, again, just like Docker, there are Kubernetes commands that we can use to set up and manage my cluster. So I have this YAML file. If I can open up this file. So this is the file that I'm going to use. And just like I said, this is a file can have multiple elements as the file, a simple file like just deploying one container in one pod probably is a very simplified way of putting it, but a file, a proper microservices would have your deployment, it would have your services, it would have your ports, or how much memory do you require for a particular pod or container to run. So all that information is captured inside this file, and this is the file that I can take and I can run it anywhere I want. Okay, if let's say if a hypothetical scenario, from here it's my cloud shell where I'm running it. What if I wanted to run it on some other tenancy, some other cloud shell of some other tenancy? All I needed was take up this file and set up my cluster on that particular tenancy and execute this file. I'll get similar results. Okay. Okay. So porting is pretty simple. Porting is pretty straightforward. Nothing complicated about porting. I could even replicate this setup on standalone VMs, not use a particular service that Oracle is providing. I could use Oracle's virtual machines and deploy the whole thing on those servers, creating a master and worker node kind of a combination. So let's see how it gets executed. kubectl, kubectl, or kubectl is the command that we use to it's a server command that we use to engage with my Kubernetes engine. So whenever I pass this command, the API server that is running would internally kind of resolve it into API and then work with the cluster to create, destroy, or manipulate, manage the cluster state. So standard command is Kubernetes apply -f and my YAML file name. In this case, it's complete-demo.yaml. So again, in this case, it's going to download images first of all, and then set up the containers inside the pod, and then we'll see how it works. Oops. Spelling mistake. So my deployments have been created. Now there are a lot of commands that you can find on Kubernetes websites. There is a cheat sheet available for Kubernetes. There are tons of commands that you can use to get all the information that you require, that is required for monitoring or accessing your pods or containers. Now my pods have been deployed. It will take a couple of minutes for them to come online. Let's see what's the status of my, let's see first of all, what are the nodes that I'm running. So I get information about the nodes. These are the nodes that I'm running. And my my containers, my pods will get deployed on these nodes. So next step would be I will see kubectl, I will see what are the pods that are running, and okay. So there is a concept of namespace. I will not dive deep into it, but there's a concept of namespace out there. So whatever you are deploying, you can deploy in your own namespace. Namespace again, if multiple people are working on multiple projects and it's a small team, and you want to create your own work area for your deployments, we use the namespace concept. Namespace kind of keeps my deployment, my resources away from other folks, so that I don't get entangled with what others are doing. And okay, it's not socks, it's okay. So all these deployments are running for me on the servers, and some are running because of sometimes because of space. If you are running multiple pods on a machine whose CPU size is small, some of the deployments may fail or may crash, but let's not worry about it for now. What I want to show you is, so there is a website that I have created now through these microservices, and what I can do is I'm sorry. I can, let me see the command here. Oops. Let me find. Okay. So what I can do is I can take the IP address of. So what I need to do is I need to take the IP address of the machine on which it is running, and let me open up the YAML file for you. So if you see, I am running it on that particular front end. I am running on 3001. That is my port number. Okay. This is the port number for front end. This is where I'm running it. So what I'll do is I will take the IP address, because I'm using node port for now for this demo, which means it's tied to a particular node. I'm going to take the IP address of the node, and this is the public IP address of the node along with the port number, which is 3001, and that is what I'm going to use for my accessing this website. So 30001. So here is my website is up and running. So if you look at the individual components of this website, these components are not running as a monolithic application. These components are running inside as microservices inside different containers. So this is not just one application running on the server. These are multiple services running on the containers. So my website is up and running. I can now do whatever I want to do with this website. I can modify, I can add few more elements to this website and work with this website. Okay, so this is how I will access my website, just like I access my WordPress application using the public IP of the node on which it was running along with the port number. Similarly, I'm using the port number 30001 for accessing the website. Now, again, this is a very simplified and primitive way of accessing your application if you are using external source. If there are multiple instances of this particular pod running, you won't use this kind of approach, because if there are 100 of nodes and you are running thousands of instances of your application, your typical way would be to create a load balancer, external load balancer, and then through service discovery kind of tie them with a single IP address, and then let load balancer take care of which node and which node needs to be accessed. Port obviously will remain the same. That's how we access, but from external side, it's the external IP address, it's the external load balancer that will take care of this IP address kind of thing. So why I'm bringing it up again and again is when you are what I'm showing you is a very simplified form of containers and Kubernetes. But once you are developing your application, you need to keep all this in mind. Your how your networking will happen, how you're going to expose your applications to external world as well as internal world, and above all, how you're going to maintain the data that gets modified, which is your persistent volumes, how you're going to maintain it, what would be the strategy about it. Okay, so my website is up and running, and I can not here, sorry, I can this is about Kubernetes, how Kubernetes works, and you can now orchestrate your application through Kubernetes. What I can also do is I can, through a command, I can auto scale them. I can set up my conditions just like we do in auto scaling of our virtual machines. We provide the conditions, whether it's CPU utilization or whether it's memory or whether it's any other reason. We kind of can provide same kind of setup via command, so that if those conditions are met, my auto scaling will happen and new set of pods will get introduced. So I can auto scale it from 1 to say X, and then based upon similar condition, you can come back from X to 1. So it's all automatically managed by Kubernetes. We don't have to worry about it, how my auto scaling would happen. So any spike will be managed by Kubernetes by itself. Similarly, I can do my own setup. It's not only the pods that get auto scaled. What if even if with multiple pods, I'm not able to auto scale, I'm not able to scale properly because there is a lot of load. So auto scaling feature also applies on the node. So one more node or multiple nodes do get attached to your cluster, and Kubernetes kind of takes care of adding them to the cluster and deploying new pods on them, and then making them a part of cluster IP. So Kubernetes takes care of everything like that. Last thing I want to talk about is, so my Kubernetes cluster is created and it's working fine. Just like I created my cluster very easily, I can also terminate or destroy my complete deployment in just with just one command. So if I want to delete everything, so I can just provide this command, and everything gets, all these pods that got created. Oops, I forgot the name, sorry. All these pods that I created, they will get destroyed very easily. Delete. So Kubernetes or Docker, it provides you ease of using these technologies. They are not complicated in terms of understanding. They are not complicated in terms of execution. But once you go the route of setting up your Docker containers and Kubernetes for enterprise grade application, you need to take care of few things, and rest of things will automatically fall in place. Good thing about Docker containerization and Kubernetes is that there is tons of material available on the web. One quick search would probably fetch you thousands of pages of information. And good thing is they are open source, so you could also participate in their open source platform. And Docker does offer you a paid version also, which you can, if you are interested, you can take up that. As far as Kubernetes is concerned, Oracle offers you Kubernetes platform. You could set up your services on Oracle's Kubernetes platform. It will create the networking for you. It will create the VMs for you. It will create all the configurations that are required to run your Kubernetes cluster. Lastly, these are some of the resources that are available. These resources will be made available to you via email after this session. Simi will send you a follow-up email. All this information, along with this, the video that we did, will be made available to you. So in case you have missed something or you have some question about which you couldn't capture the essence, or you want to talk back to me or to our team, you could reach out to me. My email address will be there in the follow-up email. Or in case you want to reach out to a larger architects team, which is spread across the globe, you could write to this email address, and we'll be happy to respond back via email, or we can set up a Zoom call with you to talk more about Kubernetes and Docker containerization. That is pretty much from my side. It was a pleasure talking to you and delivering this address to you guys. That's all from my side. Simi, is it back? It's back to you.
Thank you. I think the questions were also being answered as the session was on. Do we have any unanswered questions which Vikas can answer? I don't think so. Great. Cool. Yeah.
Simi, before we leave, once again, my request to all of you is, in case there is something that you couldn't follow, you missed, somebody disturbed you, please drop me an email or set up a Zoom call with me or my colleagues Nitesh or Nagaraj, and we'll be happy to talk to you about Kubernetes or Docker containerization, or maybe have a look at your architecture and see how these technologies can fit into your architecture and how you can go from a monolithic architecture to a microservices Kubernetes containerization based architecture. Thank you.
Great. Thank you. Thank you, everyone. And we would love to hear back from you all. Thanks. Have a great rest of the day. Thank you all.
Thank you, everyone.
Thank you.